Thank you. Welcome to the last talk. I'm well aware that after this is probably the most exciting part of the day is the cocktail hour, so I'll try to be punctual. Just a quick intro about Teradata. A lot of people may be familiar with Teradata as an enterprise data warehousing company. What you may not know is, of our roughly 10,000 employees, about 5,000 of them are actually consultants. So we do just as much development and field development work for our customers as we do work within the enterprise data warehousing space. So what that means is, today big data environments are not about a single platform. It's an ecosystem approach to solving big data challenges. And I'm a field data scientist with our Think Big Analytics, which is the consulting division that develops POCs and builds out analytic solutions for our customers. So that's taking data kind of wherever the platform is and helping build the right analytic solution for those customers. So today I'm going to kind of walk through a simplistic workflow example of building an AI process with data that we could combine from data that may be in a data warehouse, data that could be in a big data platform or some other file system, or data that could be in your Hadoop ecosystem or Spark ecosystem. So just quickly, kind of an overview of the challenge here. And I work a lot with marketers. My specialty is doing customer analytics, helping build, whether it's customer service or customer experience systems, to marketing interactions and targeting platforms. Today, whether you're in the customer experience space or whether you're in the marketing space, most of what happens in social channels at organizations is very reactive, right? What's proactive in the marketing is through paid marketing. So you put out a marketing campaign that you pay the target to them. Yes, all of our companies do posts, right? We make some public posts out there, but how engaged are those posts? Sometimes marketing controls that. Sometimes it's through a PR position. Sometimes it's through the social listening channels that are really reactive channels. So part of the problem is that these tools, the tools that people use social listening, they're mostly focused on the inbound communications from the customers, what customers are saying about you on these channels, and they don't have a lot of availability to provide tools about what you post out there, what you make public as an enterprise. And that's pretty challenging, right? Because as you see, social is becoming an ever larger part of the marketing budget. We're spending more and more money. We're shifting it away from some of the traditional challenges into social and digital channels. We would like to be a little bit more studious with that money, right? If we could get a lot more reach, a lot more promotion with unpaid marketing, that would be pretty beneficial to a lot of enterprises today. Part of the challenge with going public out there is customers, marketing don't really know what's going to work in these social channels. What's going to get the most engagement by postings? So what I'm going to demonstrate today is if you can predict the number of likes, and I'm going to show a simple example of this today. You can choose the right images to build the right audience or the targeted audience that you're after through your social channels. So the example I'm going to give today, and it's probably good to understand that we're not going to build a deep learning framework that's going to train on all the images in social channels. The process we're going to build is going to be targeted for a specific domain, which most enterprises, it is a specific domain. And in this case, it's focused on something from the travel industry. So if you're one of the travel promotion websites and you wanted to promote the sales, the deals that you have on travel, what is the opportunity that you would have to build that audience through unpaid promotion through social channels? So some examples that we have from our customers is if they can shift a lot of that budget from their paid promotion on, if they can get that same reach through their unpaid posts, right, that can save them a lot of money or grow revenue by quite a bit. So a multi-billion-dollar company growing 2% sales is a lot of money from a very beneficial base of shifting from paid social targeting to unpaid social targeting. Okay, so enough of the intro. Let's get into some details here. So I'm not good at naming, even though I work in customer analytics. So we called this project Cyclops. Not my choice, but we had to give it a name. So Project Cyclops is the basic process here. And this is a little bit of a simple, and I'm going to give some clues for how we can make this a little bit more complex and how, but to show you kind of what's available from public data, we kind of trimmed it down to the very basic workflow. So the intro is whatever the domain is. So if you're within the travel industry, so if you're Priceline, if you're Expedia, if you're Travelocity, if you're one of the main travel websites, you know who all your competitors are. Maybe you know who some of the influencers are in your industry that are making public posts. Right? We can go out and gather all of those posts, through APIs or through other means to get that data. Once we gather all that information, what's public, we can capture public data. The first step is to usually apply some pre-trained model to that. So in this case, we applied a ResNet 50 model, which is just based off the ImageNet deep learning framework. We take that image classification algorithm, and we can arbitrarily choose, say, 5 classes or 10 classes or something like that, and get each one of those classes as an attribute, as an input to our data set, and the probability that an image belongs to that class as the attribute. Now we can combine other data at this point as well, so information like the number of followers an account may have if we built a training data set across multiple followers, and then train some more advanced machine learning model, so something like a XGBoost model or really anything at that point. We could do some complex model selection criteria and try lots of different models, but to keep it simple here, just a simple XGBoost model to take those input features and predict the actual number of likes. So then the model framework, model scoring framework is pretty simple, right? We take one image as an input, we predict its number of classes, we give it that image some labels. So this bottom image here is an image from the pier at Manhattan Beach. And we can see that the pre-trained model does pretty good on it. Gives it some classes that seem pretty relevant there. And then if we also give it like the number of followers, some other metadata, if it's public, if we only have public data, we can give it the number of followers and we can predict the number of likes that would output from it. So this is just a quick, simple workflow for how this could be developed. When we do this for a customer, we actually do this. A lot of our customers, even though some of them may have deep learning infrastructure in place, a lot of them are still in the test and learn phase. So we often build a lot of these solutions in the cloud. So whether pick your cloud. In this case, we built it in AWS. Essentially, what we try to do is build everything in one self-contained environment. And that makes it pretty easy for us to update and modify and make it portable as well. Inside AWS, we had an EC2 container. This is actually a GPU container because we were running this on using TensorFlow as the backend. And inside that, we actually built several REST services. So when we wanted to update the models with new data, we simply call a REST API that scrapes new data, downloads it to our data repository, and then we can call a REST service as well to call the model training, and then actually output the model scoring algorithm as well there. Interesting, the production environment for getting scoring and feeding those scores to an application is important. Marketers often want to get some understanding of what's working in their environment as well. So from that output, we can also point business intelligence tools at it. So whether it's Tableau or MicroStrategy or something like that, we can build a simple interface that displays images and the predicted number of likes. And I'll get into a little bit more complex view of this in a little bit later example. We also have some tooling that we developed, what we call an accelerator. We call it analytic ops. So you see it referenced here in a couple places. What we've done is we've actually built a process that can pick up a model that's been trained and puts it through this REST service automatically. So this allows for quick and easy retraining of models and taking those models and pushing them into a production environment with little hands-on, actually with no hands-on. I'll show an example of it in the demo in a little bit, but we can completely automate that entire process. We'll kind of walk through it with a hands-on example, but it can be completely automated. Okay, so let's jump to the demo. Okay, so the first step is we have to build this environment. So this is an example running locally, but in an environment it would be up in the cloud. So it's very quick. Once all the software has been installed, we just quickly do a Docker build environment that installs everything and runs the whole entire system as a Docker container. And everything is self-contained. So the REST service is built with inside this, as well as the whole analytic ops framework, which is a complete software package, as well as kind of the development environment. Oftentimes our customers will have their own development environment, so we'll tack on to that in development environment as it is. So here's a quick example. So like we said, the data management process is all built through a REST API as well. So we're just quickly calling a curl step to call that API. So the scraper data actually goes out and scrapes Instagram for the post. This is just a simple example from a personal profile. So to just show how it does it quickly, it's like 29 images and its associated metadata. So all the images are downloaded as well as the metadata into JSON files. Then we want to prepare that data for our analytical purposes. So it's just another REST API that prepares the data. In this case, we're just loading this into a simple CSV file. If we're going to do this in a production environment, that's going to be uploading that to something like a Spark cluster, for our data frame. And as you can see, we just move over to our. We map this to the local drive, so all the images have been downloaded into the local file, and that prepared metadata around the post has been saved there into this database CSV file. So like we said, we had the Jupyter self-contained in this environment as well. So basically, we have the code set here to do the model training. Part of our accelerator, you can see at the top there is a quick plugin that we built to publish models to a GitHub repository. So our model versioning, so how do you get models from your development environment to your production environment really quickly? Well, the best way to do that is to recognize when you have a new version of that model, and the best tool for that is something like a GitHub repository. So we actually save, and we have training and scoring frameworks for lots of different interfaces, deep learning 4J, all the different Spark dialects, Keras, raw Python, raw R. So it doesn't really matter where you train or how you want to score the model. We can handle picking up that training process and that scoring process and moving it from a test dev environment into a production environment in multiple platforms as well. So this is real quick the workflow. Like we said, it's just a simple Keras process that's using TensorFlow as the backend. We apply that ResNet 50 model, get the classification, take that classification and feed those features into XGBoost model that does the like prediction. So let me walk you through. Once we trained that model, it's real quick to publish this to our GitHub repository. So with a click of a button here, this is a new model. So we're just going to say this is a raw Python model. Give the the whole GitHub repository has already been initialized, so we're just going to give it a new folder structure inside that GitHub repository. So we're saying here's the name of it, and here's a quick description of it. We have to create all the dependencies, so what's coming in and what's the input and what's the output of it. So this is being sent to a JSON metadata file, so we can track. And when we push it from a test dev environment to a production environment, all that's packaged up into a model.json file. So all that is being stored there. So sign that says your model's been successfully committed. We can do the same with our scoring data set. So again, it just picks up that, for a single image, does the classification piece of that, runs that classification piece. So here we're publishing that to the same repository. Nothing really different here. And since we already created that folder, so we're tying that same scoring algorithm to the same training algorithm in that environment. So this is all what a developer would see. So a data scientist, if they wanted to overwrite this model, right, they want to completely change out the process, right? Maybe they wanted to use MXNet or something next time. They can rewrite this and republish the model. If they publish it to that same repository, it's going to replace that model that's been in production. So you can see here there's the model JSON file and the model files. And then switching over to the analytics ops interface. So this interface is, I'll jump backwards there. Again, a lot of the processes for automating this, well, a lot of this would be automated in the background. A lot of our customers don't actually use the interface. But we'll just do a kind of a walkthrough of how this would work. So if we, once we go into the interface, we can select a model from the list. In this case, it says our training model. So automatically, once we published it, the Analytic Ops interface has been pointed at that repository. So it looks for any changes inside that repository. We can actually call the retraining from this interface as well, or it can be scripted to be done automatically. And then once we've run that training algorithm, we can assign the scoring algorithm to that same output. In this case, we can actually see the scoring as a REST API. So whatever attributes that we're selecting, whatever that file returns, can show up here. And here's the scoring code that's going to be output. So once that's a trained model, that was the one that was trained on about 20 images, so accuracy of about 0.12, so 12% accuracy is not very good. But again, we only did it on 30 images. Now we're going to score this. So we have the REST API here as well. So we're simply just passing the image and the number of followers, this account. So if I'm doing this on my personal account, I'll say, hey, how many images is my post from the Tower Bridge going to get? I can push that image there. How many followers do I have? It's been trained on all my images in the past. It'll output the number of predictions that it's going to get. So here it actually returns the classifications from that Manhattan Beach image as well. So again, this is a simple example for this. That API is now available. We can point whatever application that we want off of it. So if it's a BI application or if it's some marketing automation tool, they can choose from those different images, and we can feed it a folder of images. It can output the predictions, and we can sort the images based off the number of likes. Here we can randomly choose a different image from our set of images, give it a different number of likes. So this is actually a public image that was posted. And we say if it had 1,000 followers, this will output the number of likes that this image will get. So we see here it's 13,800 likes that this one is. We actually, when we changed this was a different model. This was a pre-trained model on our larger data set. I mean, so that's the end of the demo. Let me switch back. So this was a pretty simple workflow. I'll tell you when we did this for the customer, some things that actually improved the accuracy of the model beyond kind of this basic example here, using some transfer learning techniques. So instead of just using the classes as is from the pre-trained model, looking at, there's lots of texts that come associated with the images as well, and usually organizations that have a bunch of image data in their repository for marketing collateral, they have a bunch of descriptions around that image. You're doing this on public data, we don't have access to that, but using that set of text that associated with that image and learning from that text as compared to what we get from the pre-trained model gets us usually a better association. So we get usually a smaller set of classes that are more relevant to those images, and using those as features will get us more results. Also, most organizations know who likes images, not just the number of likes that they have. So we can see if you're targeting different segments of customers with different images, looking at the number of likes within different customer segments. So this way, we see a lot of organizations we go to, they're doing 1 or 2 posts a day in social channels. Now that post may be relevant for a certain set of customers, right? But so if we take the travel example, winter's coming up, right? I live in Colorado where it's cold sometimes, and I can go skiing just about any time I want in the winter. So giving me promotions for going skiing may not be that relevant to me. I'm not going to buy a ski package. I can drive up to the ski resort anytime I want and drive back down. But come February, when it's been snowing for 2 months, I may want to go to the beach. So you have these different types of customers that may be into different things. So if I just post skiing photos all winter, I'm missing out on a customer segment. So targeting the customers that are going to be most engaged with the different images and doing multiple postings that can give you the most reach is kind of where the best way to go. So finding which customers like which types of images, and then predicting not just how many likes are going to get from one image, but the total reach by posting multiple images, the total number. So optimizing for likes across multiple posts can be a lot more valuable than a simple like prediction here. We've also looked at this framework. It's pretty generic, right? So using some type of classification as an input to some type of linear prediction can be used for lots of different things. So for example, in kind of the B2B example, knowing when someone uploads their photos for their real estate, which ones are going to be most relevant to a customer. So if I upload a bunch of photos about my house, well, you didn't put one of your front yard or the backyard. That's not going to give the most engagement. You're going to get more engagement if you use these photos, right? So somewhat of a classification algorithm, but also a prediction about the engagement within that. We've looked at some healthcare examples where using image for dermatology have actually come in, so we can take pictures, have customers take pictures of their issues that they're having on their skin, and we can predict the progression of their treatments. So, are you going to need to continue treatment for 2 more weeks or 1 more week based off the images that have come in? And there's been lots of smart city applications as well, so looking at whether it's traffic flows or other information around the city, or predicting the number of people that are going to go through certain places in the city has also been an example using different still images. And then the oil and gas has also been pretty powerful around Lots of different use cases in oil and gas. Some of it's been around actually HR and staffing based off of image data that's been coming somewhat in real time off of whether it's the rigs themselves or some of the vehicles that they have. So they think of a network. They have drivers that have to service multiple locations. Understanding what's going on at a specific location through images can help route their drivers to the place that's going to be needed in a quicker fashion. But again, those are some same examples that can utilize this same framework as the base for building that. So with that, I'll leave a couple minutes for questions before we break for drinks. Yeah, in the back.
Thank you, Jack.
Hello. First of all, sincere thanks for the talk. So, question about a concern I might have when it comes to putting the model into production. So you mentioned TensorFlow. So I guess you're using TensorFlow serving for serving purposes, right?
No, we're not actually. No,
Okay.
We built our own REST API for it.
Okay, then question about that. Do you have auto-scaling for cost reductions? And is it possible to have several models at the same time in one instance?
Yeah. So we do. So we've done multiple architectures, and it really depends on the use case for that.
Okay.
If it's a real-time use case, right?
Yeah.
We may want, with a high SLA, we may want to look at something like TensorFlow serving for that. We actually have. It's actually going to be part of our product suite pretty soon, incorporated with it.
Okay, and did you try some, let's say, cluster management with Kubernetes, maybe, or Kubeflow, or?
In production, yes, we can do that.
Okay.
Yeah. So in the simple use case here, it's it's just we don't need all that as the back end. But yeah, when we ran it in production, it would be something like that.
Okay. Thank you.
Mm-hmm.
Anybody else? All right. Thanks again, Jack.